Hello everyone, thank you for joining in. I hope you all are having a great time. I am here to talk about self-service infrastructure provisioning with Terraform and AWS Service Catalog. So before we jump into it, a quick introduction of me. My name is Saptak Takalkar. I am a lead infrastructure consultant with ThoughtWorks. We are a software company and a community of passionate individuals who think disruptively to deliver technology to address the toughest challenges, all while seeking to revolutionize the IT industry and create positive social change. I have overall 10 years of experience in the industry now. I hold a master's degree in computer science from the University of Texas at Dallas, and currently I'm based out of Pune, India. So in this talk, we will see why we need a delivery infrastructure platform, what that platform is, what are components of that platform are, what AWS Service Catalog is, how AWS Service Catalog can help us in building the delivery infrastructure platform, benefits of using AWS Service Catalog, and a demo. So let's look at evolution of infrastructure provisioning. So as a stage one, we have a manual provisioning of infrastructure. Because of its limitation and not easy to manage, we have evolved into the next stage, which is automation, where we created everything as code. Infrastructure as code, pipeline as code, configuration as code, right? And this has helped DevOps team and infrastructure team to provision the necessary infrastructure requested by user in a much better way. But since the world is moving into a digital era, where a lot of requests are coming for the indispensable infrastructure, there is a lot of dependency on these DevOps and infrastructure teams. And they will get flooded with a lot of provisioning requests from the users. So to circumvent all this limitation, we have evolved into the next stage, which is self-service portal, which is nothing but a self-service delivery infrastructure platform where a user can come and get the required infrastructure provision in a self-served manner. And this is where the importance of building a delivery infrastructure platform lies. So let's understand more about delivery infrastructure platform or a DI platform. So DI platform is a platform which is fully self-service with end-to-end automation. The platform where we can have sensible defaults defined for all of our products. We can also think about the ecosystem of our organization in terms of security and the compliance requirement while building this delivery infrastructure platform. The platform is actually evolutionary in nature in terms of rolling out new changes quickly and also doing a lifecycle management of our existing products. The platform also helps in onboarding new users and new teams very easily. So does that mean DI platform is only meant for developers? Not really. So this platform should be built to support anyone in the chain of delivery, operations, and support. So they could be application teams who are actually building an application. It could be SRE team who are ensuring the operational resiliency. It could be security or compliance teams who are ensuring the product is meeting all the required organization policies, and the business and team leaders who will ensure that the objective and the goals are being met. So the main components of these delivery infrastructure platforms are products, product catalogs, workflows, security, and users. Users could be of two types. One is publisher, which mainly consists of administrators, or the DevOps or infrastructure team who are actually writing infrastructure as a code for that infra product. And the other type of user will be consumers or a developer, application team, SRE team who are going to get the required infrastructure provision through this DI platform. All right. So let's understand products and product catalogs. So product could be any infrastructure product or a service, as simple as a virtual machine in a cloud, or even servers on premises as well. So talking about AWS, it could be EC2 load balancers, or it could be auto scaling groups, right? It could be databases. It could be managed databases, self-managed databases, and then we have different types of databases. We have relational databases, NoSQL databases, right? So a product can be of any type, even a cluster. It could be a Kubernetes cluster or a data analytics cluster, and even a multi-tier application. For example, a 3-tier application which involves your front-end components, back-end components, and a databases may be packed as a monolith application or based on the microservices-based architecture, event-based architecture, or even a serverless. So a product could be of any type, and it can get provision irrespective of the location, whether we want to get that provision in cloud or do we want to get that provision on-premises. So what is a product catalog? Product catalogs are nothing but a group of products put together. And those group of products can be put together based upon their types. For example, you can package all your databases into one single product catalog. Or you can create a product catalog and group products which are based on the team's requirement. For example, some teams require 1, 2, 3, 4 products, right? So we can club those 4 products and we can create a catalog out of it. And we can even do a grouping of this product by regions. So based upon your use case, the grouping of the products will vary. And why we want to group this product into product catalogs? Because product catalog is very important. Especially it helps us in doing administration of all this product, where we can implement access management. For example, if we want a product catalog to be accessed by a specific team or a specific role, then we can introduce those security constraints in that catalog. Now let's look at workflows. So we have a publisher workflow and a consumer workflow. In publisher workflow, which would be mainly consist of administrators or DevOps and infrastructure engineers or consultants, who will first create the infrastructure product, which is actually the stage 2 of our infra provisioning evolution, where we will write our infrastructure as a code using Terraform. We will create the deployment pipelines, and we will ensure the product is meeting our organization compliance. All right. The next step is then organizing the products into product catalogs. Then adding the necessary security constraints to these products, which basically consist of authentication, authorization, access controls. And then publishing this product into different accounts and different environments based upon your use case. And once the product is available for consumption, the publisher can maintain it in terms of doing a life cycle management of it. We can add new additional product, or we can add new versions to the existing product. We can upgrade and delete the products and their versions, so on and so forth. Okay. So this is how a typical publisher workflow will look like on a DI platform. Now let's look at the consumer workflow. So consumer workflow will be users. Most of the time it would be an application team, developers, right? So the consumer workflow, the first step would be searching all the permissible product from the DI platform. Once they have selected the product, they can select which version of that product they want to get provisioned. Then they can provide their own input parameters. For example, if a consumer wants to provision an RDS database inside AWS cloud, then they can provide storage requirements, their compute requirements, what instance type do they require, right? So they can provide their own requirements in the form of inputs to this DI platform. And the next step would be launching that product with the parameters which consumer is going to provide. Launching of product internally, what it is going to do, it is going to run our IC code and it is going to provision the infrastructure for us. Okay. And once the selected product is provisioned, a consumer can again manage that product in terms of updating it or deleting it. All right. So I hope we all have got some idea about what the delivery infrastructure platform is and what are different components of that DI platforms are. Now let's understand what is AWS Service Catalog is. AWS Service Catalog at its core is nothing but a delivery infrastructure only, where we can create, share, organize, and govern the catalogs of IT services and products which are approved by that organization. So the characteristics of service catalog is again on the lines of delivery infrastructure platform only. It helps us in doing a self-service discovery of the products, and we can launch those products. Since it is inside, since AWS Service Catalog is a managed service provided by AWS, it has an easy integration with other AWS services being in the same ecosystem. It has an end-to-end automation. It can be centrally managed in an account, and whatever the products we are going to list on AWS Service Catalog can be distributed across your environments, across your accounts. And it also helps us in ensuring the compliance with our organization standards. And if you look at it, right, it is going to abstract the delivery complexity from the user. User will only see a service catalog as the only interface for them, and all the complexity of provisioning will be abstracted from them, and they will get the required infrastructure provision out of it. So at its heart, it is very much like a menu at the restaurant. Without one, customers would find it very difficult to place an order. So the components of AWS Service Catalog are same as DI platform, only the terminology changes for the product catalog. So in AWS Service Catalog, we call product catalogs portfolios. And the users will become, again, your IAM users, and that can be categorized into different groups or different roles based on their functionality. Okay. And the products, right? Products could be a managed AWS services, or it could be self-managed services, again, inside AWS, or it could be any services outside of AWS which we want to provision, maybe in different cloud or maybe on premises. So the product could be any infrastructure product or any infrastructure service. Okay. So the publisher workflow in Service Catalog, let's understand how it will look like. So again, someone in the sense, most of the time, the infrastructure or the DevOps team will create the product. What does that mean? They will write the Terraform code, they will create the deployment pipeline, and along with that, they will also create one cloud formation template. This cloud formation template it gets used to take input parameters from our consumers or users through Service Catalog. We will see that in the demo exactly how it works and looks like. All right. So once the product is created, we can organize the different products into portfolios. So we can create portfolios and we can group the products into that. Then we can add some security contracts in terms of access control. For example, out of n number of products which are published onto Service Catalog, how many of those can accessed by particular group of users, and you can add permissions to it as well. And then once everything is done, we can publish, or the publisher can publish this product into different accounts and different environments. And once the products are published, they can also do a lifecycle management of it. Now, a consumer workflow in the Service Catalog, again, a consumer can go on to the Service Catalog and they can browse all the permissible product. And out of that, they can select a product and the version which they want to provision. They can again provide the required parameter inputs to it. Again, the interface for that, internally, it would be a CloudFormation template. As I said, we will see that in the demo. And then they can launch the product. So again, internally, the IC code deployment is going to happen and the product will get provision for our consumer. And again, once the product is provisioned, consumer can manage that product in terms of updating it or deleting it. Okay. I hope we are good so far. Now let's quickly see all of this into action. Okay. So what I'm going to showcase is we are going to do a Terraform deployment, and we are going to provision an RDS database and S3 buckets through Service Catalog. Okay. So I'm inside AWS account. I have two repositories on code commit. One is for RDS database. So this contains Terraform modules using which we can provision RDS databases. And then another repository, which again has a Terraform code and which will help us to create S3 buckets. Okay. So for this Terraform code, I'm using Jenkins as a CD tool, and I have these two pipelines. So the first pipeline is going to actually run the Terraform code, and it is going to help us provision the RDS database. And the second pipeline is going to create S3 buckets for us, again, by executing the Terraform code. All right. So let's go to the Service Catalog homepage. So this is how the Service Catalog console looks like. On the left side panel, you will see we have a section dedicated for our publisher or administrator. And then a section above that is basically for the consumer, where they can search products and they can also see the products which are being provisioned. All right. So as you can see, I do not have any products provisioned over here. So let's first create a portfolio, and we will create a product to deploy our RDS database. So to quickly show you, this is the RDS database console. And as you can see, there is no database present right now. So what we are going to do is we are going to first do a publisher workflow. So let's go to product list. As you can see, I already have few products created. We have a product for Oracle database. We also have one product for S3 buckets. So let's create a new product. So I will give a name, let's say Postgres. So let's say we want to create a Postgres database. I will provide a name of the owner. I'll give my name. And then, as I mentioned that, we use a CloudFormation template to take inputs from the user. I'll quickly show you how that CloudFormation template looks like. So this is my RDS repository, and this is my CloudFormation template, which I'm going to use. As you can see, we are exposing few parameters for our consumers. So for example, database name, engine version, which port they want for their databases, so on and so forth. And then in the resources section, you can see we have a custom resource, and that custom resource is nothing but a Lambda function. So this CloudFormation template is actually going to invoke one Lambda function, and it is going to pass all the parameters for which users are going to provide an input to. And then this Lambda function is going to execute our Terraform code by triggering the Jenkins pipeline. As you can see, I'm also passing the name of my Jenkins job, which is my Terraform SC RDS demo. It matches with the one which I have on my Jenkins. Okay. So let's go back to product creation page. So I will say for this product, I want to use a template file. I will select the CloudFormation template, which I just showed you. So let me go here. It is in my RDS repository. Okay. The CloudFormation template has been selected, and let's name this as my first version 1. Okay. Then I can say create product. Okay. So the product is created, as you can see. Now let's attach this product to one of the existing portfolios. So I have already created a portfolio called as RDS. And inside that, I already have one product, which is Oracle. Now I'm also going to group Postgres product inside the same portfolio. So I'm just going to click on add product to portfolio, and I'm going to select Postgres, and I will say add product to portfolio. All right. If I refresh, as you can see, the Postgres product has been added to this portfolio. Now we want to, as a next step of the publisher workflow, we want to attach security constraints to it, right? Now, before doing that, we will attach a launch constraint. So I will click on create constraint. I will say Postgres is my product and constraint type is launch. So what does that mean? As you can see, it allows us to assign an IAM role to the product that is used to provision the AWS resources. So for example, this product during provisioning, if it need access and permission to other AWS resources, we can provide that through an IAM role. So I'm going to select an existing IAM role. So I already have one role, which is SC launch role, and I'm going to attach to this. Okay, so the constraint has been created. Now, let's come to the permission part. So I want this product to be accessed only by the databases or the DBA, databases administrator. So I can accordingly add the permissions to it. So I will say add group roles and users. So you can again, right? If you have a group of users, you can use that. Or you can, if you want to assign individual users, you can do that. But what I'm going to do is I'm going to create association with the existing role. So I'm going to say attach it with my admin user. Okay, as you can see, I have already granted the access to it, right? So if I go back here, if I go to the groups and user, you can see that I had already given the access to my admin user because I already had a product created for Oracle database, and while provisioning that, I had given that permissions to it. Okay. So once we do that, if you go to the products tab, you should be able to see the product, which is now available for our consumers. So now let's look at the consumer workflow. Now, let's say I'm a DBA and I want to have a Postgres database created for me or for my team. So what I can do is I can come onto the service catalog. I will search all the products that are available for me and which are approved for me. And from that, I will select Postgres, and then I can say launch product. Okay. And here I will have to provide some parameters to it. So the provision product name, for now, I will say generate any name. This the version 1 which we had released. Then the parameters. So this is nothing but a CloudFormation template, right? So how many allocated storage do I need? What is the database name I want to give? The database engine, the version, etc., etc. So for now, I will keep the defaults and I will say launch product. So what this is going to do is it is going to call my Lambda function. So this is the Lambda function, and this Lambda function is eventually going to trigger my Jenkins pipeline, which is Terraform SC RDS deployment. Let me quickly log into it. As you can see, the build has been started, right? So if I quickly show you the console output, as you can see, it has started doing the Terraform apply over here, right? Okay. So now we can go to the RDS console and we can refresh. And as you can see, Postgres database creation has started. And if I go inside it, all the configuration which we have provided, so it has started creating this database using that configurations. Okay. So since this will take some time, we can jump back to our presentation. All right. Before I do that, once the product is provisioned, it should be available for us in the provision product section. As you can see, looks like the Postgres database has been created and the status has become available now. Okay. Then if we want to perform few more operations to it, we can select that product, and from the actions, we can either update that or terminate that. So for the publisher, sorry, my bad, for the consumer, if you see, we have 3 actions. One is actually creating the product, updating the product, and deleting the product. So these are the 3 actions which AWS Service Catalog provides to the consumers or the users. All right. So the RDS launch product demo, which we just saw. So let's understand the execution flow of that. So when we launch that product by giving few parameters, input parameters to it, what in the background, what exactly has happened is that it has generated a create event and it has provided that details to our cloud formation. So one cloud formation stack got created, and that cloud formation has actually created or have invoked our Lambda function. That Lambda function has processed the event. It has taken out all the parameters the users have provided, and then it has triggered our Jenkins pipeline. And it has provided all that parameters to that pipeline. And that Jenkins pipeline has actually executed the Terraform code, and it has provisioned an RDS Postgres database for us. Based upon your use case complexity of your delivery infrastructure platform or service catalog, you can change the execution flow. For example, if you are a very big organization and you have created this service catalog platform and all of your users are using it, then you might want to introduce SNS and SQS, right? So the event that will get generated on the launch product action, that can, through CloudFormation, it can first go to the SNS. From there, it can go to SQS, and then Lambda can act as a trigger for the SQS, right? And this execution flow mainly talked about infrastructure provisioning through Terraform, right? And we used Jenkins as our CD tool. But based upon your use case, you can plug in any CD tools here, right? For example, let's say if you want to deploy some application inside a Kubernetes cluster, so instead of using Jenkins and Terraform, you can plug an Argo CD, right? So Lambda can create applications in Argo CD, and then Argo CD can actually, using Helm, it can do a deployment inside a Kubernetes cluster. So if you look at it, right, the combination here of creating different infrastructures are very large. For example, since Lambda is at core of this execution flow, right? From Lambda, you can call any Jenkins pipeline or any pipeline of your choice of CD tool, right? And that Jenkins could be running inside AWS or it could be running on premises as well. As long as you have a networking in place, you can do anything, right? So from that Jenkins, instead of provisioning infrastructure in AWS, you can provision infrastructure on premises. Or let's say you have a multi-cloud setup. You can even do deployment in other cloud service provider. You can do deployment, Terraform deployment in Google, GCP, or you can do it in Azure as well. So based on your use case, you can change this execution flow. And that is where the power of this delivery infrastructure platform or the service catalog comes very handy. All right. So to summarize, right? So there are a lot of benefits of using DI or a service catalog, right? We looked at self-service discovery and launch, security and compliance. We can provide fine-grained access control through IAM. It helps us in doing extensibility and version control. It helps us to improve the user satisfaction, and it can also reduce the cost as well, because only the approved services with some sensible defaults you can publish on the service catalog, right? So as a closing remark from my side, service catalog approach help us to achieve automated self-service delivery infrastructure for product teams, leading to better standardization, governance, and helps with maximizing the developer effectiveness. I hope this talk was helpful. Thank you so much. If you want to get in touch with me, this is my email ID. And if you want to network, this is my LinkedIn profile URL. I thanks the HashiCorp community for giving me this opportunity to present a talk in this HashiTalks deploy event. Thank you so much, everyone.